Hi, I want to go through the quizzes from Module 4. Give anybody that wants to watch this some review over the concepts that we learned in this module or touched on anyway. So Quiz 4.1 was actually one that I didn't give simply because in the beginning of the year I didn't have access to the quizzes yet. I'm new to this module. Anyway, long story short, I gave it later towards the end of the module, but it wasn't something that I counted for credit at all. I just handed it for kids to have. So I want to go over it. Parking garage charges $3 for the first 2 hours that a car is parked in the garage. That's a fixed rate, shown right here. After that, the hourly hourly fee is $2 per hour, and it wants us to write a piecewise function for the cost of the parking a car in the garage for X hours. So the thing that we're going to be looking at here is we're going to have two statements because we've got two things going on. Between 0 and 2 hours, we've got this flat rate of $3, but after that, we've got a sliding scale. So I need two functions sort of in one. So P of X equals, this is just 3. P of X equals 3. But when does that occur? That's where our domain statement, which is going to be the next thing here, is going to lay. So that's going to be for any value between 0 and 2 hours. So 0 is less than or equal to X is less than or equal to 2 hours. Now, this equality is necessary here, but this one is not here. It needs to be included at least once. So we'll put it here, but it could have been in another spot. So this guy here is going to have a slope of 2 up 2 over 1, so that's going to be 2x. But if it doesn't cross the y-axis, but if it did, if it continued on, it appears as though it would cross the y-axis at -1. So I can kind of use the graph to come up with that equation. And that's going to be for any value of x greater than 2. So x is greater than 2. And that's what we're looking for here. So anyway, that's what we've been working on, and that was the first quiz problem. Write the equation of the line in point slope form. This is y equals m times x minus x1 plus y1. It's where we know a point. These are your point values, and this is your slope. The x and the y are just variables. So really all we have to do is plug this in. This is going to be the x1, the y1. And it's my expectation that this be memorized. So y equals 5 times x minus 7 minus 1, or you could say plus a -1 if you wanted. Anyway, that's 4.1, and again, it wasn't counted for credit, but I did give kids a copy to practice. Now it looks like I'm a little out of order here. Good. So quiz 4.2. This was actually the first quiz given. We talked about absolute value. When we have a problem like this with absolute value, we have to take two things into consideration, because the absolute value, which is an idea of distance, of 10 is 10, and the absolute value of -10 is also 10. So it's how far away from a number line are you when you're at -10 is what we're at 10. You're 10 spaces away. The thing is, when you have an equation like this, you have to take both into consideration. You can't get rid of the absolute value bars, but you can evaluate it, and you say, okay, I know that this can equal 10 for this to be true, or it can equal -10. So we split this into two problems. W plus 4 equals 10, just as it is without the absolute value bars, and W plus 4 equals -10. Because what if that number inside is negative? Well, then we got to deal with that. So I'm going to subtract 4 from both sides here. I can do it kind of at the same time here. Subtract 4, and I get w equals 6 and w equals negative 14. They are both answers, and that was 2 points, a point for each. And then given the piecewise function below for the next one, it's saying where does 3 belong and what would the value of that be? Well, the first thing a student has to do is decide which of these two parts of the piecewise function do I plug the 3 in. Do I plug it in where 3 is less than 3? No, because that's a false statement, so I'm not going to use that. 3 is greater than or equal to 3? That would make a true statement. If I plug the 3 here, that's true, so I'm actually going to take that 3 and plug it into this guy. So I'm going to say 2 times 3 minus 4. I guess the thing that I've been saying to students is this is where the 3 lives. So we've got to work with this guy there. So 6 minus 4 is 2. And that was worth a point. And showing the work in both, showing your steps. This wasn't necessary, but this is where we got our 4 out of 4. The work and the 3 correct answers. Okay. To be perfectly honest, I'm doing this before we get all of these guys in, so I may not be able to give you insight as to how I graded them. This one has a piecewise function, and we could use this y equals m times x minus x1 plus y1, because we've talked pretty extensively about this being a point on the graph, and this is the slope. So this negative 6 actually comes out as a positive 6 because in the formula there's a minus. So it must have gone in as a positive. So I'm going to say, and this one's kind of tough because the axes on here are pretty small and hard to see, so I'll highlight those. So I wasn't real picky about where exactly. I wasn't too worried if a kid got a little bit off. Just were you in the general idea. And so over 6 and up 4, that's this point right here. Now, I'm coming down to that point. All the x values less than negative 6, I'm coming down to that point, and that's what this slope is doing. So I'm coming down with a slope of negative 2/3. So I'm going to actually take this negative, I'm going to apply it to the bottom and get to pick top or bottom. I'm going to go up 2 and back 3, up 2 and back 3, because I know that as I'm coming to 6, this is what it's doing. Because of the domain here of x is less than or equal to 6, or less than 6. Now, after that, I've got the same situation, the same point, but my slope is different. So from here, I'm going to be going up 2 and over 3, and this would be where that takes off from. And so there really isn't a lot of work to show. If a student knows what to look for there, they're good to go. So I was basically looking for a point over in this general area. Again, I wasn't too critical about whether they counted exactly 6 over and 4 up, but were they in the general area? And then a problem that some of them struggled with was this, and I think it was reading the problem. Evaluate just means plug it in or solve it. So if t equals negative 7, what's negative t? So I'm going to take this negative 7, I'm going to plug it in here for this t. So I'm going to say negative minus a negative 7, because I'm plugging that in for t, equals 7. So again, my things are worth 4 points. This one was kind of a weird one to try to make 4 points out of, but we did it and we made it. Okay, the mid-module review. We're looking for understanding and graphing the absolute value function. Absolute value functions are either going to look like this, kind of like a V, or like this, an upside down V. And here's what we've got. the form of this is f of x equals a times the absolute value of x minus h plus k. Now, this is really directly related to this guy right here that I wrote on the previous quiz. The a and the m are really the same thing. We call it amplitude, but it's the idea of slope. And it ends up being sort of a positive and a negative at the same time. The h and the k are the x and the y values of the vertex, which is the point. So I'm going to start with my vertex, keeping in mind that I've got to change the sign of the x because the formula makes that negative. So that's over 2. Looks like we're counting by 2's, and up 4. And now my slope is -1. Now, there's no 1 there. This is actually the absolute value bar, but the negative indicates 1. So, but that negative tells me that it's going to be an upside down v. It's opening downward. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And to the right, this is what this piece is going to look like. To the left, it's going to be the opposite. It's actually going to be a positive slope, positive 1. So this always indicates what's happening to the right of the vertex. And the left of the vertex is going to be the opposite of that. Okay. So hopefully using that knowledge and that formula, we can apply that here. Assuming I'm counting by 1's, this is going to have a vertex of -3, -4. I'll make a note of that. And the slope appears to be up 1 and over 1, up 1 over 1 for each sort of step in the process. So this is the h, this is the k, and a is 1. So I don't usually need to write a 1 if I'm multiplying. So I'll write this a couple different ways. I can say this is f of x, or whatever I want to call the function, equals 1 times the absolute value of x minus h. But if I'm minusing h, that's minusing a -3, that's going to change the sign of that 3 to make it positive. And then plus k, if the k is negative, it's just negative. That one just goes like that. And this 1 can be written, but it's not necessary. The other way to write this would just simply be to omit that and say the absolute value of x plus 3 minus 4. So vertex, slope or amplitude, and we are in business. All right, we skipped 4.4. We're going on to 4.5. So we're graphing this function here. It's another absolute value. So again, that's going to look like a v or an upside down v. Since this a, this 2, is positive, it's going to be the catching the water v. So my vertex comes from these values here, and that's going to be -1, -1. Why negative? Remember, this changes sign when you put that value in. And my slope, or my a, is going to be 2. So if I go -1, -1, here's my vertex. And my slope to the right of that vertex is up 2 and over 1. And the opposite is going to be true on the other side of that vertex. I'm going to go up 2 and back 1. Got some Bob Dylan playing in the background there from the other class. That's pretty good. Right, so that's what we're looking for students to do and see, and those are the shortcuts. One thing, just a quick mention, if you as a student get lost or something, you can always pick some values for x and y. You know, let's say you pick -2 and -1 and 0 and 1 and 2, and you plug those values into this and very carefully solve those problems, you'd get these guys you'd get that v. So it's shortcuts are nice, but they're not the only way to do it. The function f of x is shown on the right. Graph f negative 1 of x. This is the inverse. So basically x's and y's change. So what I'm going to do here is I'm going to make an x and a y table for the values that we have. And so I'm going to look at this point, and this point. And I'll write those down. So it appears, again, kind of tough to see here, it appears that this is my y-axis and this is my x-axis. I'm going to go with those. So for this point here, I'm looking at this one, that's going to be a negative 1, 2, 3, 4, 5, 6, 7, and up 2. So I'll write that in there. X is negative 7, y is 2. And then this guy here is going to be negative 1, negative 2. If I'm seeing that right, I think I am. Yep. And then this is going to be over 1 and up 4. Now, for the inverse, f, this is f of x. F negative 1 of x is simple. All we do is take our x and our y and we swap places. We don't change the names, but they change place. So the x becomes 2 and the y becomes negative 7 for this point. The x becomes negative 2 and the y becomes negative 1. And then the 4 and the 1 switch place. So for the inverse, the x's and the y's switch place. That's all an inverse is. So now I'm going to plot those points and see what that looks like. So if I go 2, negative 7, I've got a point here. And if I go negative 2, negative 1, I've got a point here. And if I go 4, 1, I've got a point here. So, how do I graph that? I'm going to pick one more point because the problem I'm seeing here is, do I connect it this way? Do I connect it this way? Do I connect it this way? If I connect this point to this point to this point, we run across a problem that makes it's not a function. So I'm going to do some checking here. I'm going to throw another point in here. This guy right here was between these two, and so that is 0 and 1. So how about 1 and 0? So if I graph that, over 1 up 0. 1 and 4, negative. Okay, well, looks to me like this is the answer that I need to be looking for, which, strangely enough, does not make a function. Anyway, so a way to kind of check there. The other thing, we need to move on. Lots to talk about on that one. All right, and the last quiz. Find the inverse of the function. Haven't taught this yet, but this is what I'm going to teach. Take the h of x and make it y. And then remember, inverse switches x and y. They switch place. We saw that in the last problem where I wrote the point values out. But in this case, I'm actually going to take the y and put it here and take the x and put it there. So I'm going to say x equals the square root of y, or I could leave the h of x there, but I think it's kind of ugly if I do that, plus 1. And now what I want to do is solve for y. So I'm going to subtract 1 from each side. So I get x minus 1 equals the square root of y. And now, how do I undo a square root? I got a square, but I've got to square both sides here. So I'm going to say x minus 1 quantity squared equals y. because these guys will cancel. And that is a form, and it's the form that I would kind of expect from the students at this point of this answer. It's factored and we're in good shape. Number 2 is going to be the same. So I'm going to call this y. Probably, I'm going to take this one more step. Probably a best way to answer this, though, would be to say x minus 1 squared equals, remember it's an inverse, so if I bring that function notation back, h negative 1 of x is just a fancy way of writing, hey, saying I'm an inverse of a function. So, again, I'm going to change this, and I'm going to say x equals, changing the y and the x in place, the square root of y minus 2 plus 1. So this is going to be minus 1. Let's get rid of that first. So x minus 1 equals the square root of y minus 2. Can't really do anything with that minus 2 at the moment, so now I'm going to square both sides to get rid of that square root. So I get x minus 1 quantity squared equals, these cancel, y minus 2, and then I need to add that 2 to get that back over to the other side. So x minus 1 quantity squared plus 2 equals y, but I'm going to rewrite that as f negative 1 of x. It's the inverse of the function that we started with. And that is what I'm looking for on all of the quizzes for this module. So I hope, for those of you that might take a minute and watch this, I hope that some of those clarify some things and help you with the test. Remember, you can bring in that note card of notes.